Hello everyone, I welcome you to yet another lecture under Concept Clarity lecture series by Clarity for Sure and Agriclarity platform. And today's topic of discussion is the rocks and the classification. Okay, so yes, let's just start with our today's topic. So rock is what? Rock is a hard solid mass of a mineral matter that is composed of one or more rock forming minerals. Okay, so it is nothing but the combination and composition of minerals. Okay, it is combination and composition of minerals. So yes, like in soil science, we have the concept of edaphology and the pedogenesis, right? On the similar line, we have here two concepts. First is a petrology and second is a petrogenesis. Okay, so let's first discuss the petrogenesis. We know genesis is what? It is origin. It is origin and petro means rock. So petrogenesis is the study of origin and the formation processes of rock. Okay. But the petrology is what? Logy is study we know, logos is science, study, and petra is a rock. So it is the study of rocks. It is a scientific study of rocks, including the classification, description, composition, etc. Okay. So petrology is the study of scientific study of rock, and petrogenesis is the study of origin of rock. Okay. So yes, this is the basics about the rock, the petrology, and petrogenesis. So we have different classes of rock, and under the classification, we classify rocks based on different methods of formation and etc. into three headings. Okay, first one is igneous rock, second is a sedimentary rock, third one is a metamorphic rock. Again, igneous rock is further classified as intrusive and extrusive rock. The sedimentary rock is further classified as a clastic or chemical rock, and the metamorphic rock could be classified further as foliated and non-foliated rock. You can see the difference from the pictures, how these three rocks are different from each other. Okay, so now let's just discuss each one of these rocks one by one. Okay, let's start with the igneous rock. So igneous rock is the primary rock because from igneous rock the rock cycle. Okay, the rock cycle starts. Okay, it is made up of the core. It is made up from the core of the earth, that is volcanic magma, lava. Okay, so yes, it is a primary rock because it is the start, the first step of the rock cycle, and it is made up of the lava or the magma from the earth inner part. Okay, so ignis is the Latin word which means fire, and it is formed by cooling and consolidification of magma. Okay, it is formed because of cooling and consolidification. So here we have two types of igneous rock. First is intrusive and second one is extrusive. The name is only suggesting that what is difference, right? So intrusive is this cooling and solidification is happening below the surface, below, inside the surface. And extrusive rock is where the cooling and solidification is happening at the surface, X out on the surface, right? So yes, this is what is difference. So intrusive rock is also called as a plutonic rock, and extrusive rock is also called as a volcanic rock. Okay? And here are the two terms I want you to focus. That is, in intrusive we use term magma, and in extrusive we use term lava. There is no difference. These both things are same. What is difference is that this intrusive rocks are formed from magma, and we use this term magma because it is inside the earth. But when that magma managed to come outside on the earth's surface, then its name only is going to change. That is lava. Okay, so both things are same, only the name is different. Which is inside is called as a magma, and which managed to come out on the surface is called as a lava. Okay, so this is the only difference. Okay, so examples of kind of important. At least the basic examples are important for your examination. So intrusive rock, the examples are granite, gabbro, pegmatite, and for extrusive, the examples are basalt, volcanic breccia, and tuff. Okay. So you can see here the intrusive from magma, which is inside the lab surface, and extrusive out, x at right, and which is made from the lava because it is managed to come out. Okay, so this is what is the igneous rock. So now let's discuss the for in detail the classification of these igneous rocks. So first is extrusive. We already studied this, right? It is consolidification or the cooling of the magma on this earth surface. The magma that reaches the surface is called as a lava, right? We see in a general, right? It is volcano. Like we are able to see it with our eyes, right? So yes, it is X, it is volcanic, and it is lava. The next is the these rocks cool rapidly and are usually finite. So there is one more concept here. Please be attentive. So these plutonic rocks are inside. Okay, so they are inside the Earth's surface. So to cool down, it is going to take time. Okay, so the process will be slow, and when the process is slow, the the rock which is going to form from this will be large. Okay, it will have enough time to be together, stick together, so it will be large. But in the case of volcanic or extrusive rock, it is cooling in the atmosphere, right? So it is fast. The process is fast, and because it is fast, it is going to cool down individually, and the grains will be fine. They will be small. Okay, so this is the only thing here. It cools rapidly. As it is in atmosphere, the cooling is faster, and because of that, they are going to cool individually, making them fine grain. Okay, but here the rocks here this plutonic rock is going to cool down slowly, and which is going to give that rock time to be together, to be stick together, which make it as a large rock. Okay, so this is the one concept here. So yes, so examples in extrusive rock are basalt, rhyolite, etc. And the intrusive rock is what? It could be plutonic, it could be hyperbaric. So what are those? Let's discuss. So we studied, right, solidification of magma below in intrusive, right? So we have two, plutonic and hypervasive. When this solidification is happening at greater depths, then it will be called as a plutonic rock. But when it is happening at shallow depths, then it will be hypervasive. Okay, so here are the examples: granite, gabbro, dolerite, etc. And yes, there is one more concept, the seal and the dike. Okay, so when it is solidified in the vertical cracks, then it will be dike, and when those solidify in the horizontal cracks, then it is a seal. So seal and the dike. Okay, so yes. Next concept is the vesicular rocks. So vesicular rocks are formed when the molten magma cools quickly on the surface, trapping the steam of water or gases inside. Okay, but that steam or the water is going to eventually exit out of that rock, leaving this cavity, this vesicle, this holes, and giving this particular look to this rock. So they are called as what? Vesicular. These cavities or holes are called as a vesicle. So these are vesicular rocks, which are formed because of they trap some steam and water inside them, and after that steam and gases leave that cavity is formed. Okay, so example is pumice and sodium. So yes, these are the igneous rock. Then the classification of igneous rock based on the silica content. So it could be acidic, basic, or intermediate. When the silica content is more than 65, it is called as acidic rock. And when the silica content is between 40 to 55, then it is called as a basic rock. So examples of basic rocks are gabbro, basalt, B for basalt, B for basic, gabbro. Again, we have B here. So these are the basic rocks, and the example of acid rocks are granite and rhyolite. So yes, this is about the classification of igneous rock and overall igneous rock. The second one is the sedimentary rock. Okay, so these Sedimentary rocks are also called as stratified rocks because they create some layers like structure. Okay, or they are called as a secondary rock because they are formed from the igneous rock. Okay, the metamorphic rock and sedimentary rocks are called as secondary rocks. So the term sedimentary is derived from the Latin word sedimentum, which means settling. Okay, what is settling? So these rocks are formed through natural sequence involving weathering. So the igneous rock is going to put under some erosive forces or some weathering forces, and it will be broken down into the small pieces. Okay, the weathering is going to happen, then those particles will be transported by different transportation agents like wind, then water, okay, ice, glaciers, and these will be deposited at the lower uh, slopes. On the lower slopes, or when the forces of those, when the energy of those erosive forces will reduce, they are going to get deposited. Okay, and after deposition, these the process called lithification happens and these sedimentary rocks are formed. So what is lithification? Lithification is a process of turning this sediment into solid rock, okay, which involves two key steps. First is compaction and second is cementation. So compaction is a pressure underlying these rocks is going to make it compacted or compressed, and the cementation is the process. These gaps will be filled with some cementing agents and it will be created. Okay? So minerals participate and bind the sediments together, and compaction is going to apply pressure and going to compress it. Okay. So cementing agents, some of the examples of cementing agents are silica, iron oxide, calcium carbonate, etc. So now let's start with the classification part. Classification based on the origin for the sedimentary rocks. Okay. So yes, first one is residual sedimentary rock, and second is a transported sedimentary rock. In residual sedimentary rock, it is formed by in situ weathering without much significant transportation. That is, it will be there in a residual form in situ with the parent rock. Okay, so yes, there is not much transportation here, and the example is the laterite. Next one is the transported sedimentary rock. It will be moved from its place of origin with the different transporting agents. Okay, first is the solid in suspension, second is by chemical precipitation, third by the agency of organic matter. So first is solid in suspension, that is from the mechanical weathering, and they are physically transported. There is no any chemical changes, there is no any chemical processing or chemical reactions that are taking there are not those chemical reactions. Okay, it is done with the mechanical weathering and they are physically transported. Examples are sandstone, shell, and so yes, this is deposited as solid in suspension. Next is deposited by chemical precipitation. It is formed from the precipitation of dissolved minerals from the solution. So what is happening here? That mineral will dissolve into the solution, and after some time it will be precipitated from that solution. Okay, so it will dissolve, will be carried with that solution to another place, and there it is going to get precipitated. So yes, this is what is chemical precipitation. Examples are limestone, ironstone, etc. Next is deposited through agency of organic matter. It will be accumulation of organic material with it, and it will form, that is peat and phosphatic deposit. So yes, next is this classification of sedimentary rocks based on the grain size and composition. Okay. So first is rudiceous rock. If the sizes of the grain is boulder or pebble size, if the fragments are boulder and pebble size, then it is called as a rudiceous rock. Example is conglomerate. When the size of those particles is a sand size, then it is called arenaceous. If they are cell size, then it is called the sills rock. Then if it is a clay-sized particles, then it is called argillaceous rocks, and they are primarily hydrated aluminosilicates. Okay, example is shell, clay, mudstone, fuller's rock, earth, etc. Next is siliceous rock, and they are formed mostly from organic silica from microscopic organisms like diatoms. Okay, example is chert and flint. Next is carbonaceous, that is carbon, high carbon content and it is formed from the plant remains under anaerobic condition. Examples are peat, lignite, bituminous coal, anthracite, etc. Next is calcareous rock. Calcareous rocks are mainly calcium and magnesium carbonates. They could be organic origin or they could be chemically originated. Okay, examples are limestone, dolomite, chalk, then coral, etc. Okay, this was the classification of sedimentary rocks and overall sedimentary rock under the classification of rocks. Next and the last important rock is called as a metamorphic rock. This is again secondary rock. Okay, the sedimentary rock and metamorphic rocks are called as a secondary rock because they are formed after few changes in the igneous rock only. So metamorphic means change of form. That is, these metamorphic rocks are formed from igneous and sedimentary rocks under the heat, pressure, and volume change. Okay, so this heat, pressure, and volume change will change its form. It will change its mineral, the overall molecular structure, texture, color. All the physical and chemical properties will be altered because of this heat and pressure exposure. Okay, and it is called because of all this reason it is called as a metamorphic rock. These things form because of deep burial, because of tectonic forces, then contact with rising magma, which will increase the temperature and heat, then the pressure of overlying rocks, okay, and this will lead into the recrystallization and reorganization of minerals which are present under the rock, and it will change its form and giving its new look. Okay, so these are the examples: shell, slate, phylaceous, and needs. Okay. Yes, so under metamorphic rocks, we have a concept called metamorphism. So what is metamorphism? We see, right? Change of form. So we have different metamorphisms. First is dynamic, second is a thermal. So under dynamic, it is caused again by the mechanical disruptions and reorganization, that is crushing and breaking, and there is no major chemical change. But under thermal metamorphism, it involves chemical alterations and recrystallization due to it. So dynamic is because of mechanical disruptions and thermal is because of chemical alterations due to heat. And the under thermal we have two subtypes. First is contact and second is the regional metamorphism. So contact is localized. Okay, uh, it is the direct contact with that particular rock and which is going to change its form. But the regional is large occurring over large areas due to tectonic pressure and the heat, which lead to its recrystallization. So contact is kind of localized direct contact with the rock, and the regional is occurring on the larger scale. So yes, so the next concept under metamorphic rock is the structures in metamorphic rocks. Okay, so first is the foliation and or the lineation. So foliation or the lineation means the minerals are arranged in the layers or lines. Okay, you can see the layers or lines in here. This is called as foliation or lineation. And the banding is what? It is alternating light and dark layers of different mineral groups. You can see the clear difference here, right? One is a light, one is a dark. This concept is called as a banding, and the rocks with these bands are called as a banded rocks. Okay, so yes, and the types of metamorphic rocks we have two types. First is foliated rocks, and second one is a non-foliated rocks. So foliated rocks shows visible layering. You can see the layerings in these two rocks, but non-foliated rocks are without layers. Okay, these are the non-foliated rocks. It is that simple. Okay. So yes, this chart is important. These are the metamorphic rocks and these are the sedimentary rocks. These gone through different processes like high pressure, high temperature, and it changed into metamorphic rock. So this quartzite is formed from sandstone, marble is from limestone, mica slate is from shell. So the questions in your exams could be like, the origin, the marble is formed from which sedimentary rock, like that. Okay, so please just cover or revise the chart once. Okay. So yes, this was about the today's lecture, and these are the two practice MCQs. So pause the slide and comment down below the answers for this two MCQs in the comment section. So yes, this was it for today. Thank you so much for watching. See you in the next session.